Good afternoon, students. This is again Pragnesh Ploara from Roma Engineering College, Junagadh. Let us continue with the solution of Advanced Mathematics Group 2, and we have solved already question number 5A, and currently we are solving question number third example of question number 5A. We have already solved 2 examples of question number 5A. So let us look at the solution of question number 3 of 5A. And the third example is evaluate this is again the integration of 2x plus 1 into in root of x square plus x plus 9 dx. Okay, we need to evaluate this function 2x plus 1 in root x square plus x plus 9 into dx. Before we solve this example, I want to remind you one formula to integrate, that is if there is an integration like this, fx raised to n into f dash x dx, that is equal to fx raised to n plus 1 upon n plus 1 plus c, where n is not equal to minus 1, when n is not equal to minus 1. In this method we can find the directly answer in this way. If we look at this example, then here if we take fx is equal to x square plus x plus 9, then this is fx, this is the square root, that means this is fx raised to 1/2, and the differentiation of f with respect to x, that is f dash x, that is differentiation of x square, that is 2x, differentiation of x, that is 1, so 2x plus 1 plus 0. That means if we put fx is equal to this one, then we will get f dash x equal to this one. Then this is example like fx raised to n into f dash x into dx. So we can solve this example using this formula. So in this case, let f of x is equal to x square plus x plus 9. Okay, implies f dash x is equal to, as I told you, that this is 2x plus 1. So using this fx and f dash x, we will get this one is equal to, so implies integration of 2x plus 1 into in root of x square plus x plus 9 into dx is equal to integration of, this is x square plus x plus 9 raised to 1/2, that is square root, into 2x plus 1 into dx, this is fx raised to n into f dash x. This one is fx raised to 1/2 into f dash x into dx, right? So by this formula, this is fx raised to n into f dash x into dx, that is equal to fx raised to n plus 1 upon n plus 1 plus c. Here n is equal to 1/2. In this case n is equal to 1/2, so I will get this one is equal to fx raised to 1/2 plus 1 upon 1/2 plus 1 plus c. That means I will get this one is equal to fx is equal to x square plus x plus 9 raised to 1/2 plus 1, that is equal to 3/2 upon 1/2 plus 1, that is equal to 3/2 plus c. So after all, this one is equal to 2/3 x square plus x plus 9 raised to 3/2 plus c. So this is the final evaluation of the integral 2x plus 1 into in root of x square plus x plus 9 into dx. So let us just recall this example. This example we have started with this question. So here I have used this formula, that is fx raised to n into f dash x into dx is equal to fx raised to n plus 1 upon n plus 1 plus c, when we can apply this formula when n is not equal to -1. Here n is equal to 1/2, so we can use this formula. Fx is equal to x squared plus x plus 9 and f dash x is equal to 2x plus 1. Using that formula, we have get fx raised to 3/2 upon 3/2 plus c. That means x squared plus x plus 9 raised to 3/2 upon 3/2 plus c. Okay, so this is the final solution of this example. હું એ વસ્તુ પણ ક્લિયર કરવા માગીશ કે એવું જરૂરી નથી કે આ એક્ઝામ્પલનું સોલ્યુશન આપણે આ પર્ટિક્યુલર ફોર્મ્યુલાનો યુઝ કરીને જ કરી શકીએ. આપણે ડાયરેક્ટ મેથડ ઓફ સબસ્ટિટ્યુશનનો યુઝ કરીને પણ આ એક્ઝામ્પલનું સોલ્યુશન કરી શકીએ. તો હું એ મેથડનો યુઝ કરીને પણ આ એક્ઝામ્પલનું સોલ્યુશન કરવા માગું છું કે જેથી દરેક વિદ્યાર્થીઓને આઈડિયા આવે કે આપણે એ એક્ઝામ્પલ એ રીતે પણ સોલ્વ કરી શકીએ. તો આપણે એ જ એક્ઝામ્પલ સેકન્ડ બીજી રીતે હું સોલ્વ કરું છું. ક્વેશ્ચન પાછો હું રિપીટ કરીશ. ક્વેશ્ચન છે ઇવેલ્યુએટ ઇન્ટિગ્રેશન 2x plus 1 into in root x square plus x plus 9 into dx, right? So now I am using the method of substitution. The last method is also the method of substitution, but we have used the direct formula. Here I am not using any shortcut direct formula. Okay, here I am taking let x square plus x plus 9 is equal to t, right? Let x square plus x plus 9 is equal to t. So by differentiating both sides, I will get differentiation of x square, that is 2x, plus differentiation of x, that is equal to 1, that is equal to dt by dx, because differentiation of 9, that is equal to 0, implies 2x plus 1 into dx, that is equal to dt. Okay, so here we have 2x plus 1, here we have into dx, so I can put 2x plus 1 into dx, that is equal to dt, and here in root x square plus x plus 9, that is equal to t. So this will be now in the format, this one is equal to, this one is equal to integration in root t, this is in root t, this one 2x plus 1 into dx, that is equal to dt. So this one is equal to integration root t into dt, right? So after simplifying this one, I will get this one is equal to integration t raised to 1/2 into dt, and by the simple formula we know that the integration of t raised to n with respect to t, that is t raised to n plus 1 upon n plus 1 plus c. So integration of this part will be t raised to 1/2 plus 1 upon 1/2 plus 1 plus c, that is t raised to 3/2 upon 3/2 plus c, and by replacing the value of t, this one is equal to 3/2, so this is 2/3. T is equal to x square plus x plus 9 raised to 3/2 plus c. So as we have solved this example before this one using the another method, so answer will be same, 2/3 x square plus x plus 9 raised to 3/2 plus c. So in this way we can solve this example directly by the method of substitution. Okay, so this is the solution of example number 3 of question 5a. Let us quickly move to the solution of question number 5b. Question number 5b is attempt any two, and the first question is question number 5b, and the question number 1 is evaluate integration x square into log x dx. Before I start the solution of this example, I want to remind all of you the method of integration by parts. Okay, because we need to use the method of integration by parts to solve this example. એટલે કે આ એક્ઝામ્પલનું સોલ્યુશન કરવા માટે આપણે ખંડશ સંકલનની રીતનો યુઝ કરશું. સો પહેલાં આપણે ખંડશ સંકલનની મેથડનો આઈડિયા ક્લિયર કરી લઈ. By the method of integration by parts, integration u into v into dx is equal to u integration v dx minus integration into bracket du by dx integration v dx, the bracket over, into dx, right? So u integration v dx minus integration of du by dx integration v dx, the simplification of this bracket, and the again integration of this solution with respect to x. So in this way we can solve integrate the multiplication of any two function of x. And the another question is how to select u and v. That means જો બે ફંક્શન આપેલા હોય u અને v બંને એક્સના ફંક્શન હોય તો એનું ઇન્ટિગ્રેશન આપણે ખંડશ સંકલનની રીતે આ રીતે કરી શકીએ. પણ ક્વેશ્ચન એ છે કે u કેને સિલેક્ટ કરશું અને v કેને સિલેક્ટ કરીશું. તો એના માટે પણ આપણા માટે એક ઓર્ડર છે, એ ઓર્ડરને આપણે ફોલો કરશું. એ ઓર્ડર છે LIATE. આ ઓર્ડર પ્રમાણે આપણે u અને v નું સિલેક્શન કરીશું. ધેટ મીન્સ L એટલે કે this is logarithmic function, this is I means this is inverse function, A means this is algebraic function, T means that is trigonometric functions, and E means that is exponential function. તો આ ક્રમ પ્રમાણે જે ફંક્શન્સ પહેલાં આવતું હશે એને આપણે u તરીકે અને પછી આવતું હશે એને આપણે v તરીકે સિલેક્ટ કરી શકીએ. ધેટ મીન્સ વી કેન સિલેક્ટ u which function is coming before in this order. So first function is u and the second function is v. So using this rule we can integrate this example. In this case we have two functions. First function is x square, okay, and the second function is log x. If we select u and v using this method, here we have log x here. So log x is coming first in this order. So first coming log So we say that u is equal to log x. જે ફંક્શન પહેલાં આવતું હશે એને આપણે u કહેશું. તો log x છે એ આ ક્રમ પહેલાં આવે છે, આ ક્રમ પ્રમાણે પહેલાં આવે છે. તો u ઇઝ ઇક્વલ ટુ log x અને પછી જે બીજું ફંક્શન હશે એ ઓટોમેટિકલી v તરીકે સિલેક્ટ થશે. સો ઇન ધીસ કેસ u is equal to log x and v is equal to x square. ઓકે, તો u is equal to log x અને v is equal to x square લઈ અને આ ખંડસ્થ સંકલનના ફોર્મ્યુલાનો યુઝ કરી આ એક્ઝામ્પલ આપણે સોલ્વ કરીશું. તો આ ફોર્મ્યુલા પ્રમાણે આવશે ઇન્ટિગ્રેશન ઓફ x square into log x into dx is equal to, here u is equal to log x, so u integration v dx, that is integration x square dx, minus integration into bracket differentiation, that is d by dx of log x into integration of v dx into dx. That means u integration v dx minus integration differentiation of u, that is du by dx, integration of v dx into dx, right? So this is the method of integration by parts. So here we will get this one is equal to log x integration of x square, that is x cube by 3, that is x raised to n plus 1 upon n plus 1, minus integration differentiation of log x, that is equal to 1 upon x, integration of x square, that is again x cube by 3 n into dx. This dx is here. Okay, this is the